Musical instruments are designed to produce sounds that may be played during songs. Instruments may be hit, plucked, rubbed, provided with air, or involve a keyboard input. Most songs are designed to be played to standard pitches, so instruments are tuned to the 12 notes of the octave. Other instruments are untuned and are used to set tempo or rhythm for songs.
Claves, also known as rhythm sticks, can be made from broom handles cut to a 20 cm length. They are played by clapping them together with the hand cup to increase the volume and to focus the sound produced. Percussion instruments can be hit with different types of sticks, with the shape of the heads controlling the type of sound produced. Sticks can be made using 5 mm diameter doweling and some beads. To create hammer-shaped heads, a thicker piece of doweling can be glued onto the 5 mm doweling. Shaped hammers can also be made from some softwood. Bamboo can be cut and the fibres bent without breaking to create brushes for a softer sound. Some drums require tensioning membranes to produce their sound. I created a waisted drum using 2 flower pots and pieces of calico cloth for the membranes, but when I tightened the string to tension them, the fabric was torn before any appreciable sound could be achieved. The calico was not strong enough, but the string also did not tighten uniformly through all of the holes. I read about an instrument called water drums, which change pitch when the shape of the gourd used and by the amount that the gourd is submerged in water. Increasing the air pressure inside the gourd, I attempted to create one of them with yogurt containers, but the buoyancy of the air pocket within them and a lack of space prevented it from working efficiently. A uniquely Australian instrument is the lagerphone, which is constructed by hammering bottle tops with washers into a broom handle the height of the user. I also attached a headpiece with 24 bottle tops to the lagerphone, which increased the volume of the noise that it creates. The instrument is played by banging the stoppered broom handle end onto the floor and by rubbing a toothed handle against it. I did not have the time to make this additional piece. Tambourines and other jingling instruments may also be made using pierced bottle tops.
Vibrations in different materials produce vibrations in the air which can be heard. I think that the vibrations correspond to frequencies of standing waves that are produced, assuming that those materials are hit in appropriate positions and with vigour to create waves in that material. Vibrations travel at different speeds in different materials, so the length of those materials will need to be judged based on experimentation.
A tuned percussive instrument that can be made are tubular bells. These are different lengths of 2 cm diameter aluminium pipe cut to decreasing lengths. They were then filed to create the required note and were tuned using the electronic chromatic tuning device. Another tuned percussive instrument I created included some wooden keys for a xylophone made from a door frame lip, 1 cm by 3 cm and of various lengths. The pitch of the key increases as the length of the key decreases. This was also tuned using the tuning device. Another xylophone can be made using equally sized bottles with different amounts of water filling them. They vibrate at different rates. The greater the volume of water, the lower the pitch. It is possible to create a note just by blowing over the lip of the bottle.
Pythagoras devised a system of tuning based on the lengths of strings. A string which is half the length will vibrate twice as fast as the original string. Other notes are calculated based on ratios such as 2:3 and 3:4 of the size of that string. This is not the system that is used today to specify the spacing between notes, which is known as equal temperament. Some of the notes in equal temperament are close to those devised by Pythagoras. The standard is 440 Hz as A above middle C. The notes above and below this are derived by multiplying this standard by 2 to the power of note divided by 12, where note is an integer number above or below 0, which is standard. This includes the sharps, also known as flats.
The tuning of strings depends on their length, tension and thickness of material that the string is made from. Fishing line stretched over a sound hole produces a pitch that gets higher with increased tension. The same effect occurs with guitar strings. Instruments using air might require breath from the operator to power them. The human voice could be described as one of the best natural instruments. It is possible to sing and hum by controlling the vocal cords. Humming can create a wide range of pitches, but this effect is enhanced if you place your lips to a comb with a piece of grease-proof paper covering it. The sound is greatest with a greater area of your lips placed on the comb with your lips far apart. I created a few whistles from bamboo of different lengths. Only one worked for unknown reasons. I placed a dowel with a small cord hole in both the front and back of the bamboo and carved an opening at the front end of the whistle. A different length of bamboo should produce higher or lower pitch. This is evident when a recorder is played and the appropriate hole for a note is unblocked, effectively shortening the length of the tube. Harmonicas create noises of different frequency when they are both blown through and when air is sucked through them. They use reeds which vibrate at fixed frequencies to provide the sound through each of the holes. Another unusual instrument that uses air is a musical pipe, which is corrugated and produces a higher note when it is swung quicker. Only certain notes may be produced by this action. The length of the tube does not change, but the frequency can be doubled or tripled if the speed is quick enough. The control method for producing sounds is important. An effective method for producing sounds is a keyboard, which presents the different notes in increasing pitch. An organ uses the keyboard and a foot-powered bellows to direct the air through different path lengths to create sound, whereas a piano uses the keyboard to pluck tuned strings. An electronic organ uses electronic circuits to produce its sound. A theremin uses electronic circuits, but its method of control is unconventional, as it uses position of the hand to control tone. I built one from a kit, but do not think that I have tuned it correctly. The volume increases as you lift your hand higher, and the pitch increases when moved closer to the antenna. The electric guitar has an electromagnetic pickups that detect the vibrations of the strings.
There are an extremely large amount of musical instruments which may be created. Some instruments have become more popular than others based on how easy they are to play and the sound that is produced when they are played. Instruments make use of vibrations in air created by different lengths and shapes of materials. The control of a musical instrument is a highly valued skill and requires an understanding of the way the sounds are produced and a good amount of practice.